Thank you. All right. That's the only reason I needed it. Okay, an on-ramp update. The multiple UPF release is on. I don't see him. Gabriel, thanks for all of your help with that. He told me that it was going to be he's going to get it merged this any day now, but this week.
Okay, cool. You're welcome.
Let me just note that. Ransom, Wuzhong, I see that you're on. I created a Google Doc with your proposed redesign of Ransom. What we'd like to do, just general announcement here, is schedule a discussion or review of that document, and it involves several people who do not regularly attend this call. So, well, I do see Alex there. So we will get a review of that scheduled and see if we can start to get some work products out of that.
Yeah, that sounds good. So probably I think I can prepare some sort of slide deck or something to go through it, and probably later this week or early next week. So if we can schedule at that time, I can present it. I can propose my ideas.
That would be great.
Yeah.
And Wujong, could those slides please contain just like the base? I mean, what we currently have, just to be on the same page,
yeah,
where we want to go, but where we are. Okay, thanks.
Of course. Yeah.
Okay, thank you. Since you're here, Wuzhong, is there anything else that you have to status updates anywhere?
So I have one more status update for on-ramp, SD-RAN on-ramp. So it's almost done. I'm actually testing. I'm doing some final tests on the single node cluster and multi-node cluster now. So probably the initial code for SD-RAN on-ramp will be merged this week. So once it's done, then I think I can ping you, and then probably next TST meeting, I think I can also announce that it's ready.
Beautiful, thank you.
Yeah.
All right. Is there anything else someone wants to, other topics people want to raise?
I have a question, kind of like what is the kind of the path to move forward regarding on-ramp and Ether in a box? Is Ether gonna box be out of kind of like maintenance and then just move everything to on-ramp, or what is the plan for that?
Well, we haven't firmly made that decision, but it's rapidly becoming the case that on-ramp has parity with Ether in a box and is now incorporating some additional things. Maybe most notably is the updated work on actually the Moza Lab Genode B. But be that as may, yeah, I mean, that's basically the summary. There's ongoing work with on-ramp, and people are obviously still using Ether in a box, and they're producing good results with Ether in a box, and there's no reason to stop that and cause people to shift. But in terms of ongoing updates of Ether in a box, it's harder to see the path forward on that.
Yeah, I'm asking this because last week I think we opened like 2 or 3 PRs kind of related to that, so that's why we kind of like want to make sure, you know, whether should we kind of keep concentrated on Ether in the box for future work or just move into on-ramp from that perspective.
Well, yeah, I'm not personally keeping Ether in a box up to date, and Andy is the keeper of that, so to speak. And it's he's got other obligations, so I don't know what Andy's thoughts are on that.
I have not had any time to invest in Ether in a box recently. So yeah, as far as I know, it's pretty much unmaintained right now.
Yeah,
So
that's
just the one thing I can add is that GS Labs is tasked with, I'm not quite sure the right word here. I'm going to just use the word migrating. Features. So for example, a few weeks ago, we heard about the high bandwidth tests that were done in the context of Ethernet box. Those are very straightforward to also bring up on ramp, and that's on this back up to that integration testing status. Part of what's going on there is to replicate. Maybe that's a better word. So I mean, that would be my personal opinion, but we haven't decided that collectively. We can give GS Labs a little bit more time to get some of these most recent upgrades running. Why don't we take this up as a major discussion point next week? I don't want to. This one could go quite a way. So why don't we?
And Larry, will it be possible to have a list of the features that needs to be replicated?
Well, so right now it's the high speed. There's two things in the works. One is the multiple UPFs, which I know, Gabriel has helped get that parity established, and that is talked to Bilal yesterday, and he was going to bring it up, this week, or merge it yet this week. The other is the high speed throughput tests, and that we have all the data we need for that now. We have the values files. It's a reasonably straightforward process to use those value files in on-ramp. It just needs to be done. So just take away to the GS Lab folks, this is a priority. And so we need to not, and there's several threads to it, and we need to not get stuck on just one of those.
Right. Sure, we'll take it on priority.
So I will make it a priority next week to give everyone a status report on where we are with the on-ramp work. And with any luck, we will actually have a couple of new additions by then. And then we can discuss this more thoroughly. Anything else? Just kind of clean up my notes here. All right. Why don't we shift to the second half, and I will stop sharing. And Jessica, I'm pretty sure I saw you on. I don't know who's going to be doing the talk, though.
Hi, Larry. Hardik is doing the talk.
Okay, so I will stop sharing and let you grab the screen and introduce yourselves. And go ahead and give your presentation.
Sounds good. Thank you. And hello, everybody. Good morning, good evening, good afternoon, from wherever you are connecting. My name is Hardik. I'm one of the co-founder and CTO of GXC. We're a small company based in Austin, Texas. We primarily on the commercial side focus mainly on private networks, both for enterprise and DoD. But we also work on, as part of some of our DoD projects, we work on a lot of open source stack and integration and testing, etc. And so in our talk today, wanted to talk a little bit about some of the work that we've done with SD Core, Ether in a Box, and some other open source stack. And then also discuss maybe future collaboration interests, ideas between like with all the members of the ONF. And so let me start with some of the work that we've done so far. We have built some test beds for some of the DARPA programs in collaboration with some of the performers there at DARPA, but also like DoD agencies like NIVIC PAC. We also have our test bed for Linux Foundation's 5G Super Blueprint project. And as a part of some of these work, we have done some integration, hardening, and testing of open source cores, like SD Core being the main one, but also a few other cores like Pre5GC, Magma, etc. Very recently, we demoed a UPF and SMF slicing on SD Core using commercial UIs, and I have a demo video to show about that. Some of my team members did work closely with some of you folks to make that happen. We also did did the SD Core with our proprietary RAN, but also an open source 5G RAN called SRS RAN. Did some testing with that, and so I have a couple of slides to go over that. And then hardening of some of the open source cores, hardening of SD Core, porting SD Core. So we've done some work with the government on porting some of the core on trusted, untrusted hardware platforms, like some. So from an infrastructure perspective, like having the stack run on various kind of scenarios, which are interesting to me. We also participated in NTIA 5G Challenge recently. If you're following that, it was like a plug fest, primarily focused on the RAN side of things, like Open RAN interfaces, integration between the radio and the core, etc. And then we are, if anybody's interested, we're doing a workshop in collaboration with SRS RAN. We're actually doing a demo there of an end-to-end system, and so that's upcoming if anybody is joining there. So overall, so just kind of like a highlight of our 5G work is primarily we are we very much want to use the open source stack end to end, so both RAN and the core and some of the orchestration, network management, etc. And they want to bring that to commercial markets, especially enterprise private 5G sort of things. And so some of these work we've not been very active in the community in the sense of attending the meetings and providing inputs, but we've been quietly working with some of the team members here and trying to deliver on some of these DoD efforts. And so I wanted to take this opportunity to kind of update everybody on some of the progress that we've made. And also I want to keep this conversation very collaborative, and feel free to stop me anywhere if you have any questions. So our setup on 5G SE looks something like this. Maybe it's it's pretty similar to some of the other setups. We have, I was kind of trying to, to share last slide, we have integrated this platform end to end. Have tested a bunch of UEs. As a part of that, resolved a lot of issues, whether it be on the RAN stack or in some cases the UE stack, the UE settings, configurations, frequency mapping, etc. And so where we come into all of this is to do a whole lot of real world end-to-end testing using commercial UEs like we have here, and also some UE emulation testers, which could do a whole host of tests, and will come in upcoming slides.
Could I jump in with a quick question?
Yes,
I see
yes,
you're using band N78. Is that, do you have any notion of where the industry's going? We're seeing the latest Sericom is they're focused on N48, and I was wondering what you know there.
Correct, yeah. So N78 was N78 was our starting point. So N78 is like from 3.3 to 4.2 gigahertz. So it's a pretty big band. But typically, N78 is kind of like has been used to notion 3.7 to 3.8 gigahertz of spectrum. That spectrum, 3.7 to 3.8 in the United States, is primarily operator spectrum, and like between AT&T and Verizon, they have certain licenses in that spectrum. In Europe, though, a combination of private networks, operators, etc., use N78, 3.7, 3.8 gigahertz. We have recently started also, we have an N48 setup already. And so, the other thing I wanted to mention is our stack on the RAN side is an O-RAN stack. And we have this 7.2 split. And that means that, like, typically a G Node B, like for example, the Sericom G Node B is kind of like an option to, I'm guessing it's an option to, which means that like some of the layer 1, layer 2, and layer 3 are integrated into the box, versus here it's a little bit of a disaggregated where layer 2 and layer 3 sits on a cart server, like the one shown in the rack, and then just a layer 1 physical layer or actually a part of the layer 1 is in the radios, which are there on the left hand side. And so that allows us to, we can switch the RUs, radio units easily for different frequencies. And so we've done N77, N48. We are starting to test a lot of N48 devices and user devices with N48, and also coming up with some end user device challenges as the ecosystem is evolving, and working with some of these end user chipset stack vendors to kind of figure out. Typically, typically the operators do tests like PTCRB, if you're familiar with it, where they would, like for example, if an iPhone works, if an iPhone comes out, like AT&T and Verizon will put it through certification and testing, so that it absolutely works on all sorts of architectures that they may have nationally, right? And just to make sure that there is no impact on end user experience. That's not so much the case with these new upcoming frequency bands, and also new upcoming use cases like private networks, right, where the stacks are new and different, and primarily inspired from open source, and then also the bands are different, right, and so and so the role we're playing here, and as a part of some of this, is also doing a lot of integration, but also a lot of doing integration and verification of end user devices, so that we we make sure that some of these devices work, and it in general helps the overall ecosystem as some of these things get figured out, and probably like feed or propel the mission of having private networks in some of these spectrums. So yeah, like post N78, like this is just the work that we concluded a few months ago. We started working on N48. We're also working on other spectrums like N79 and 77.
Thanks. That's great background. Thanks.
Yep. Yeah. And so this is some of the test results here. In terms of like kind of peak throughput, we've achieved 100 megahertz, 1.6 gigabits per second. But we've also done like 80 megahertz, 40 megahertz, 60, 20, 40, so smaller bandwidths as well, or configuration of smaller bandwidths as well, depending on the use cases, etc. Let me go to the next slide. And so as a part of testing some of this, we've also tested like these industrial devices, like for example, this industrial router, having them connected. And all of these things have happened on SD4, as an example. And we've done lots of tests on these things. These are some results on end-to-end testings, where like we're kind of having an RF connected test setup, which is emulating, in this case, 16 UEs, like 4 UEs, 8 UEs, 16 UEs, and like various configurations of UEs per TTI, and concurrent connections, etc. So really trying to push the system where we want to test like 256 UEs, 412 UEs, etc. Initially, right now, for some of the private network use cases, we're talking about limited number of UEs, not talking about millions of UEs, but it's more kind of the distributed architecture, which is of more interest, and I'm going to come to that and some of the future work that we can do together. This is some results on SRS RAN. So SRS is an open source RAN stack, and we use that in some of our tests, where to integrate with SD4, to integrate with the real RU, to integrate with the real UEs, etc. And so some of the test results here. Doing 2x2 MIMO, 4x4 MIMO, 1x1, etc. And so let's go.
Another quick before you go on. So I heard you say Apache a few minutes ago in reference, I thought, to SRS RAN. I was under the impression that's not the license that they have. Is that? Can you confirm that?
No, I didn't mention Apache, but we are using SRS RAN is what but no, I don't think they have Apache license.
I thought it was a GPL based license.
It is GPL based. Yeah, it is
Okay.
GPL based. Yeah,
okay,
that's correct. Yeah. Yeah.
Okay.
Okay.
Thanks.
So one interesting thing we did with SD core is network slicing, and primarily we did SMF plus UPF slice and with the RAN here, and wanted to show a video demo if that is of interest. Feel free to stop me if you have any questions while I play the video here. And let me know if the video comes across. yeah, I can talk through some of these things. So this was our setup for the slice, and so we had two SMFs, two UPFs set up, and some of my colleagues, Abhishek and Paul, you can feel free to jump in to talk to some of these things. We had it set up such that both the UEs are in two different subnets, connecting to two different UPFs. And so here's where we are starting the GNRB, getting the GNRB going. And so it's just kind of saying this is all happening on the real end-to-end setup. So once we have GNRB up and running, like the CU, the DU, that come up, the L1's up, and then so now, and also DU comes up. So the GNRB gets connected to the AMF. Well, once that happens, then here we would connect two different UEs. So the first UE is, I think, Galaxy S21, I think, which is like now 5G connected, and as you can see the video session establishment, and then we will run some iPerf tests, get the iPerf going, and then we can see some of the packet captures here going with the one, and then I think we try to do a second ones with an ASUS. And so bring it out of the airplane mode, get the 5G connected, and then this is second use is on a different subnet, and a different slice of the network. So even though both of them are like kind of similar types of devices, like cell phones, but we're really trying to demonstrate that we can set up two slices here. And so we limit the throughputs on slice 2 versus slice 1 to kind of demonstrate their capability. Here, I think we're trying to show the IP addresses for both, showcasing that both of them are on two different subnets here. The one's on 172.252 and 172.250. I see, and I think we run a few FTP tests or try to access one particular subnet and do video feeds, etc. RB, Paul, Abhishek, anything you would like to add in addition to this?
No, I don't have anything to add this. You're right on.
Just a question from my side. This is Alex. I saw on the picture with the rack, you have a server with ONAP. Is that in any way used in this demo? I'm just curious.
We're starting to do some work on that, on integration, and we are also thinking through whether to use ONAP or between ONAP, Netrio, and Pronto, maybe three projects, and also thinking through between network orchestration and then software stack lifecycle management piece, both of them. That will be the next steps here.
And it would control the run somehow?
Yeah.
That's the purpose?
Yeah.
Okay. Mm-hmm.
Yeah, control. Yeah. And then the next steps will also some of the next work is also to we did we're planning to use the other ONF project being SQRig. And doing some integration with the RAN system that we have here for and then using some XApp. So I'll come to some of that.
Great, thanks.
Question: you indicated that you have a single SMF per slice. What is the reason for that?
Yes, so we did. First, we did do. Where is it? We did do one SMF and then multiple UPF. So we did demo that also, or we did implement and demo that also, and then wanted to do SMF slicing as well. And so just demonstrating that we could slice the SMF as well.
Mm. Okay.
So by slicing the FMF, you would have predetermined which UEs were going to which SMF. It's not like you're load balancing, correct?
Correct. Yeah. At the moment, yes. Yeah. RB.
Yeah. So yes, you could. One of the things that use cases here, that you could do is, you have isolation of complete networks and control plane, right? So one of the things you could do is you could do another one with the AMF slice as well, but we in this case, we chose to do one AMF, and you could assign separate UE pools and things like that as well with that SMF UPF pair. I mean, you could do it with other way as well, but this gives you a little bit more isolation in terms of security.
Sure.
For command.
There is work going on in our, the ONF community on scaling the AMF. So you may want to connect with that or at least know about it.
Sure. Okay. Yeah.
Did you have to do any changes in the SD code to get the SMF slicing done, or was it just through configuration?
It's mostly through configurations. Yeah, we did have to make some modifications on the database, and Abhishek and Paul can talk more about it if you like. There are some
configurations and mostly changes to the hem charts. But mostly configure related changes. Yeah.
Okay.
Yeah, currently the way that if you just deploy it the way it is, then it will not create those nice slices, right? And you have
that's what.
Yeah. Mm-hmm. Yeah. Okay. Anything else specific to this, or? Okay.
Yeah, maybe. Okay. Here are some of the ideas. And so before I come to the ideas, I also wanted to share. We do as a company use some of these stacks. Not as decode yet, but some of the stacking doing some real world deployments. As a company, we have 25 to 30 or so private networks deployed so far, various settings like campuses, etc., in various technologies like both LTE and 5G, depending on the use cases and industrial and smart ag, campuses, venues, that kind of application. So some of this is influenced by some of the work that we have done in the real world field, and it's just you having SD core and SRS RAN would influence our next generation architecture as well. So yeah, here are some ideas that we've been discussing about certain next steps that we want to work on or we'll be working on. The first one being AMF slicing, like RB was talking about. That is of interest. multiple settings, but also some of our customers are interested in it as well. Excuse me. Yeah, and then RIC integration with our open source RAN stack, demonstration of few XApps on the real RAN. So, for example, current XApps that's developed under ONAP primarily ransom based development, and so we want to do some integration with our ORAN stack to have some real world application, real world data going, etc. Using RIC to enforce certain SLAs at the RAN level, but also on video sessions. RP can talk more about that. Want to demonstrate transport slicing. So transport slicing is like the transport between RAN and the core. And in case of private networks, I mean, also for public networks, most of the times transport is multi-site over the public internet. In some cases, it's a combination of blend of public network, fiber, satellite, etc. And so having a end-to-end control slicing for that is pretty very interesting. Multi-site network deployment. So this is something we're discussing with some of our customers on deploying the architecture that I just shared on multiple sites, getting insights from there. So let's go from distributed RAN, distributed core, distributed SD core, and then like managing orchestration that network orchestration and stack orchestration being part of that multi-site, inspired from that. And some sort of lifecycle management for both of these software stacks, but also for RIC and for the network management system. So they're kind of broad stroke ideas. They kind of these some of the efforts which are on top of the stack development. That the work that's going on is a part of ONF. But also it's kind of bridges the gap between the real world application of some of these and the development and the open source software, both network software as well as the RAN software. So welcome any thoughts and any feedback on some of the work we have done, and I'll probably drop in my email in the chat if you would like to get in touch about anything specific or would be interested in any collaboration.
So I think the way to think about this is one of the reasons for inviting you is just to expose everyone else here to the kind of work that you're doing, so they can go, aha, that's what we're working on too. So these would tend to be pairwise in some way. Certainly on the AMF slicing, the Purdue research is there, but that's in collaboration with some folks at Intel as well. Some of this, Alex, for example, on the RIC integration with the RAN stack, that might be a connection. So I'm sort of putting this out to everyone on the call here to follow up on this. Almost everything on your list has overlap with what we're doing. So it's a matter of finding the individual projects to run with. I mean, Aether, just onto the last three, Aether has a fairly end-to-end deployment orchestration component or components. Some of those are in an existing deployment and kind of hard to apply to somebody else's deployment, which is the retooling that OnRamp is trying to address. But OnRamp hasn't gotten to and won't get to for a little while the multi-site deployment aspect of it. But that would be, if you're going to do that, then that would be a good thing to collaborate on.
Yep. Yep, absolutely.
Yeah. I think along with some of these, I think it'll be great to find exact kind of requirements and use cases, and the kind of the data flow paths that you're looking at, and see if we can work together. Yeah.
I mean, the one that to me is most interesting opportunity is your open source RAN stack at the below the RIC, and then the RIC that we have integrated back with our core. That would be the that would be the top example for me anyway.
Yeah, that would be full stack open source. RAN and the RIC. Okay, I think that's all I had for today. Feel free to reach out to us for any questions or any collaboration opportunity. And thank you, Larry, for giving us an opportunity to talk through some of this. And then maybe we'll probably do this again every quarter, probably based on the progress that we make going forward.
So there's a question for you in the chat.
Yeah. Right. On some of the CBRS deployment, we do have a SaaS domain proxy, so to support one step, single step, what I mean, going to a SaaS domain proxy, and then we have the RAN controllers that would do. They'll control the radio as a proxy. And that's also like, for example, for some of the RIC, one of the XApps that's of interest to us is on like really doing coordination, frequency channel coordination based on the SAS grants, and some sort of avoiding interference, but also maximizing the channels that we can get, or the throughput that we can get from the channels that are available from the SAS at a particular location, and that could be an interesting orchestration application. So on the SAS case, the domain proxy. So we have a controller, kind of like a domain proxy that would run non-real time in the cloud, and then that talks to SAS, and then the domain proxy has a slave radio controller. That radio controller controls the RU, CUDU, but mostly RU in case of SAS, and it will be an RU and DU because of the frequency parameters and bandwidth parameters, etc.
Other questions? All right, thanks. And to the extent you've someone on your team or in your group could participate in the TST just to keep the connection established and hear progress we're making on this side, that would be great. And thanks a lot. There's a lot of touch points here.
Thank you.
So before we adjourn, an update on the Jenkins issue. Daph had sent me a note and I hadn't seen it until I got a chance later on here that he was working on the problem as we were meeting. So I don't have an update on it, but if he is on it, and he hopefully will make progress. Is there anything else? All right, well, we have at least one agenda item for next week, which is to, I'll give you an update on some of the most recent things that have been going on with on-ramp and how, and have the discussion about how to position on-ramp versus Ether in a box and both of them, or start migrating, or exactly how we should manage that, manage those two. So see everyone next week. Thank you.
Larry, I just wanted to say, I mean, if Daph could give some kind of even a daily summary on Slack, that would be useful, just so we know where things are.
Yeah, I will tell him that he should ought to do that. Thanks, Sean.
Scott.
All right, thanks everybody.
Thank you.
Thank you.
Thank you.
Bye-bye.
Bye.
Bye.